Okay, welcome to Epic e-learning web class. Today we'll be doing IPv6 address planning. So when I'm saying we'll be doing IPv6 address planning, it means we'll be discussing how you can plan your IPv6 address when you are going to deploy IPv6 into your network. So when we'll discuss about the planning, we'll use some case study, right? So we'll just do some real address plan based on some case study. So yeah, and then from there you get an idea, and then you just use that same concept, some ideas, or some knowledge to do your own address plan. Make sense? So that's what we'll be doing today. A little bit of introduction about myself. My name is Nurul Islam Roman. I'm the technical training officer now in Epic. As you can see, my job title, my core responsibility is to kind of do technical workshop, transfer technical knowledge to our members so that it will help them to build and operate internet effectively. All right, so yep. We also have an FAQ on our website www.apnic.net/e-learning support. So if you have any difficulties, I would say technical difficulties, right? When you are watching this web class, yeah, it worth to have a look on the FAQ to kind of resolve some of your common problem that you might face. Okay, and finally, we acknowledge Cisco system because they help us to kind of in terms of sharing ideas and knowledge to prepare this model for you. And when you finish the workshop, we would request you to kind of spare some time and give us a feedback. This is what the feedback URL. I will be presenting the feedback URL at the end slide, so that you will have that URL handy, and you can just give us some feedback. Your feedback is very important for us because this is how we try to improve our future e-learning session. All right. So let's move forward. Okay. We are doing IPv6 address planning for ISPs or for enterprise. When we do the planning, the first question is, where can I get the address from? No, the basic address, the very basic question. Well, as you know, the current registry framework of internet numbers, right? From the central registry, which is IANA, there are 5 regional internet registries. So if I name them, like Afrinic, they look after African region. Then we have APNIC, they look after Asia and Pacific region. Then we have North America, they look after Aryan region, right? Then we have LACNIC, they look after Latin America region. And finally, we have RIPE NCC, they look after Europe and Middle East region. Okay. So yeah, so if you need or if your company belongs to or situated in any of the region, and then you should go to the your corresponding registry and get the address from there. That's what the registry structure is. We are in Asia Pacific, so APNIC is the registry to give address in Asia Pacific. Okay. If you see the geographical region among the registries, APNIC works in Asia Pacific. That is where APNIC region in here. You see, this is the region APNIC works. We distribute address to nearly 56 economy, right? Our country. And yeah, and also, as I said in the previous slide, we have LACNIC, they work on Latin America in here. We have Aryan, they work in American Internet in here. Then we have RIPE NCC, they look after Europe in here. This is what European internet, and then we have African for the African internet in here. All right, so those five internet regional registry can give you a portable prefix, either V4 or V6, that you can use into your network. When I'm saying portable, means that address has been given to your organization. You build your network using that address, and then just arrange routing with your upstream. So since it's portable, if you move your upstream to any another operator, it still can carry your address. That's what the portable address means. Okay. When you need to get address from any of the registry, what the first thing you need to do, you need to be a member of the registry. So when you are becoming a member of the registry, right, then you request for address. So when you request for address, all the registry, they require a plan from you, and that plan is obviously based on 1 year requirement, right? So yeah, so when you send that address request, make sure your plan is based on 1 year requirement. Sometimes we saw some members, they do plan based on per customer, like every month they send a request to Epic, but this is not the right way to do it. Because if you do it that way, most likely you'll get discontiguous block for different requests, right? That's why we request you, or we advise you to do a request for 1 year plan, so you'll get a contiguous one, the bigger block. So general allocation policies, we have, so for example, for the service provider network, if you're a service provider, so for example ISP or telcos who has got internet customers, for them we do allocation, which is by default /32 in IPv6. And for the enterprise customer, if you're an enterprise, so in that case you will not have any internet customer, so that IP address will be used into your network. That's what we call enterprise, right? A bank is also an enterprise, considered as an enterprise, right? Even though bank is a service provider, but they provide banking service to their customer, not internet service. So in terms of internet application, bank is an enterprise. Okay, so as an enterprise, when you receive address from the registry, so for example in APNIC, you will receive /48 by default. If I summarize, as a service provider, you receive /32 by default. As an enterprise, you receive /48 by default. You can get more, but if you need, but in that case, you need to justify why you need more. Okay, yeah. So that is what the default allocation and assignment size in IPv6 /32 for service provider, /48 for the enterprise. Okay, this is what one option to get a portable one, right? And the second option, if you don't want to get a portable one, and if you are happy with the non-portable one, so for example, if you don't want to be a member of the registry because you don't have any budget for that at that moment, so what you can do, you can get address even from your upstream ISP, right? So to whom you are receiving internet service, you can ask them to give you a non-portable address. So when an upstream ISP will give you an address, that will be a non-portable one. What does that mean? It means if you move out from that upstream service provider, you need to return that address back, and with the new upstream or new service provider, you receive a new block, and you need to renumber your data center with the new block, right? So that's what non-portable block. Okay, so yeah, so when you receive non-portable block from your upstream, if you're building your own data center, if you have a requirement of multi-homing, you need a /48, that's for sure, right? To get a routing arrangement with the upstream internet. So if you have a plan for multi-homing, right, it's better, it's advisable that you get a portable block from the registry. Okay, that will make your life easy, and it will make things easy for you as well. So addressing plan, ISP infrastructure. So ISP will receive a /32 from the registry, which is the minimum allocation. You can get more if you can justify, but normally /32. From that /32, you need to cater different part into your infrastructure as an address, and also you need to cater address to your customer. So there are two, visibly two area into your network. One is your infrastructure, and other part is your customer. So within your infrastructure, you might have loopback for every routers, right? You might have point-to-point link in between routers. You might have point-to-point link in between your POP router and your customer router, like customer CB, and then the POP router. So that is also considered as infrastructure, right? But that is customer side point-to-point. So point-to-point link, we have two types. One is in between our routers, and other one is in between customer routers and my router, right? Yeah, so the recommendation when you do address plan for the ISP infrastructure, generally we use slash 64, 1/64 for every router's loopback. /64 is the prefix, and from there /128 prefix goes to every router's loopback, right? Yeah, so that's what the advisable things. From 1/64 it goes to the different router's loopback. That is applicable in a situation where all your router belongs to the same region. If you have a concept of regional operation, like you have an operation in Australia, you have an operation in Singapore, you have an operation in Japan, it depending on your topology, it depending on your like an organizational kind of organogram as well, like how those different region has been administered, right? If you think those different region is a different entity, right? So for in that case, probably different block can be used for that regional router's loopback, right? It depends. Okay, so normally, in the service provider network, what we do /48 per region for the infrastructure, right? And if you see the majority of the network that we have, /48 even enough for the whole infrastructure. And also depending on your summarization requirement. If you need to summarize, and based on that, you have to distribute addresses for different infrastructure component, infrastructure part of the network. Okay. What about LAN? So when you have LAN, so on the LAN, what is the prefix that you can use? So the best practice is per LAN or per N site /64, right? What does that mean? Say for example, in your network, you have a number of departments. You have a physical network LAN into your office, and you have a number of departments, right? 10, 20 departments. So what we do in current situation, we create a physical LAN, right? And from there we create different VLAN for different department, and that is how we actually isolate the layer 2 traffic, right? So this is what that LAN topology that we currently have. And in IPv4, what we do, each VLAN we give a subnet, right? And depending on the number of hosts they have, if in one VLAN you have 10 computer, you give them a for example 28 probably, right? And another VLAN, if you have 20 computer, you give them a /32 probably, /27 probably, right? So this is how we do different subnet or variable and subnet for different VLAN, which makes sense for IPv4. But in IPv6, things are very different. How it is different? Per VLAN /64 subnets. Doesn't matter how many computer they have in each VLAN. 10 computer, 10,000 computer, 164 per VLAN. Because if you see the IPv6 address structure, our network prefix is 64-bit. We can't go beyond that, right? That is how most of the vendors they build their CPE, right? So per VLAN /64. Even if you see some operating system, if you go beyond 64, so like 70, 75, you'll have a very hard time to make things work. So that is what very strict rule on the OS or vendor level, because they need some sort of standard as well. That's why they're very strict on that. So per VLAN, the recommendation is /64. Doesn't matter how big it is, how small it is. Then point-to-point link, like WAN link. According to RFC 6164, per point-to-point link allocation is /64. right? So you have two point-to-point link or three point-to-point link, then three separate /64 per point-to-point link. But if you use on the device level, when you configure like point-to-point link 1 CPU side router, on interface you use /127 or 126, right, on the device level. But the allocation for that point-to-point is /64. Now if you need to cater the second point-to-point link, then you give them second /64, and from there on the device level you use 126 or 127. Then when it goes to the third point-to-point link, don't go for the adjacent /126 from that /64. Go and get a separate prefix /64, and from that 64 use 127 on the interface level. So this is how we can secure our point-to-point link. If you need to run any BGP, on that one interface address, the BGP peering address, right? And if your address range is /64, that can give huge option, like for the network abuse or the network DOS attackers. What they can do, they can send us some sort of ICMP message on that interface, and when those interfaces need to do neighbor discovery process, that will never end, because 2 to the power 64 is the scope of the neighbor discovery. Yeah, so that is how we can secure the point-to-point link. So according to RFC 6164, per point-to-point link allocate /64, but on the device level use 126 or 127. But that things is still under hot discussion. People are going for different options. In future it might be changed, but this is what the RFC as of now. Make sense? Okay. Addressing plan for the customer get 1/48. So when you give address to your customer, right, you give /48 to your customer. I mean, it's a big kind of dispute here. Why /48 to each customer? Because my customer don't need like number of hosts which is like 2 to the power probably 96, no, or 90, yeah, 2 to the power 90, yeah, we don't need that much, right? Okay, the idea is, if you see your customer, if they want to be multi-homes, so for example, they are connected to you, and for the link redundancy purpose, they're also connected to another ISP, right? So they're multi-home. So if they are multi-home, and if they receive less than /48 from either you or from other ISP, they cannot do any BGP specific announcement with that prefix, because in BGP, if the announcement goes to the internet, the legitimate prefix is /48, right? Because if you see in the internet routing table, most of the big transit operator, they have a very strict aggregation filter, right? They only accept /48 and /32, not any prefix in between 32 and 48, not 47, no 46, no 45 normally. But you can arrange that in case by case. But normally they have a strict aggregation filter. /48 and 32 is permitted. Rest of the prefix not permitted. So that is why from day one, when you do address plan, make sure you provide /48 per end customer who will be multi-home, right? Okay. Then who will not be multi-home, like end users? What is the deployment plan for end users, home users, right? So for the home users, you can give /64, you can give /56, or anything in between, right? Normally the best practice according to the IPNIC addressing guideline, /64, if you are 100% confirmed, your customer will have only one link. What is that? Say for example, any of your customers connected to your ISP using DSL, right? So what do you do when the DSL device, the CPE, will be authenticated with your BRAS or PPPoE server? Then your PPPoE server should do a prefix delegation, or any of the IPv6 DHCP server within your network need to do a prefix delegation towards their LAN side of the customer on the DSL. So prefix delegation is /64. It means DHCP server is not giving a single address to any of the machine. What DHCP server is doing, or the PPPoE server is doing, they're giving a prefix, the whole subnets to that LAN. Did you see the difference? Prefix delegation, not a single IP address for the LAN machine, but a prefix for the LAN. So when you do a prefix delegation of /64 for the customer side LAN after that, DSL CPE. So for example, they have a Wi-Fi there. So for the whole Wi-Fi link, /64 will be the network prefix, and last 64 will be either auto-configured MAC address or whatever the policy customer has got. Based on that, they will build their network. So if you see the scope in the customer link, within that link, they can grow up to 2 raised to 64, right? So 2 raised to 64 is nearly infinite number of addresses that customer has got in their network to grow within that Wi-Fi, right? So this is what we call only one link, like one Wi-Fi. What if customer has got another link after that? Say a television, like Wi-Fi enabled television or smart TV that connects to that access point. And there is a remote that connects to the TV, not to the access point, right? So remote connects to a different link, not on the same link. So if the remote connects to a different link, remote according to the IPv6 protocol architecture, it has to be end to end. Then from where remote will get a /64 prefix, because per LAN or per link prefix is /64, right? So in that case, there is no more prefix for the other link. So that is why the second option, if you think your customer will have more than one link, and which is the most likely case, you should not give a /64 to per customer. You should give more than /64. The best practice according to Epic guideline /56. So if you give /56 prefix delegation towards your customer, right, then your customer can create another subnets. How many subnets they can create? /56 and /64 subnets. So 8 bits, 2 to the power 8 equal to 256 number of /64 customer will have. Then they can cater 64 per link, and then in each link they can grow to the power another 64 number of hosts. So that is what the plan. Make sense? Any questions so far? Okay. So customer address assignment. So you should not reserve anything for POP. So what you do, just do your plan for 1 year or 2 years, a limited time, and how many address you need, and the principal that you have in each POP, same as IPv4, right? So for example, your external prefix will be carried within infrastructure using IBGP. Your customer will connect to you using either BGP or static, not through any IGP protocol. That's what the best practice that we use in the service provider network. Backbone infrastructure, if possible, you can use 1/48. A single /48 can cater the whole infrastructure if it's a kind of one region. Yeah, and then we also can aggregate, and we need to aggregate in the IGP, because in IPv6 the prefix length is too big, and that can populate huge number of subnets into the network, right? So aggregation is very important in IPv6. That is why most of the service provider normally they have a strict aggregation filter into the network. Okay, so address plan for the infrastructure of an ISP. Phase 1. What do you do in phase 1? So you have a /32 given by the registry. So what you do, that /32, you create two different parts, right? The first part from the beginning here you can start as infrastructure, and from the end you start as customer, right? So you're growing your infrastructure from here to this direction, you're growing your customer from here to this direction. In future, if you need more address, so for example from Epic will give a contiguous one for IPv6, right? So that will start from here. So in that case, even though for your customer side, you still can aggregate, right? You see the aggregation option? That's the beauty of starting from two different sides. But if you start your infrastructure from here, then your customer from here, and then again infrastructure from here, customer from here, then you lose that aggregation option in between your infrastructure and into your customer. Make sense? So that is what an option that, the best practice rule that you can follow when you do that address plan. Make sense? Okay. As I said, the first time when you receive a /32 from the registry, and when you need more in future, then you will get another /32, and to /32, as I said, it will be contiguous, so your total prefix length will be /31. Okay, So if this is the plan for the registry to allocate, so you should also plan your addressing in that way. So that is what we discussed in the previous slide. Now we'll do a sort of an example address plan for you. So we took two case study. Let's see those case study. So we do one subnetting for option one. The option one is for an ISP who is growing on the internet access customer. So ISP is only growing on the internet access customer, probably not on the data center, say on the internet access customer. The second option is for ISP growing on both data center hosting and internet access customer. So in those two scenarios, what would be the best addressing plan? Let's have a look. Let's take option one. In option one, ISP with growing with the customer. So say for example, we have a /32 from the registry, right? So that is what the /32 from the registry prefix parent block. That parent block, we just give a block number 1, right? And for that parent block, what could be the reverse DNS domain or the ARPA domain, the infrastructure ARPA domain? As you know, like in IPv6, ARPA domain works on each hex digit, right? So that's how we'll start. So 240664000:32, right? The ARPA domain will be 0.0.4.6.6.0.4.2.ipv6.arpa. That is what the infrastructure ARPA domain. Second opinion is a policy requirement. So for any of the prefix is going to your customer which is greater than /48, you need to send a second opinion request to APNIC. So since this is a parent block, you don't need to send any second opinion request. Registration requirement, the host master, when they will give you the address, it's their responsibility to register the parent block into the WHOIS database. Okay, so yeah, that's what the plan. So the block one, so when you distribute or do the plan, as you can see, or as we saw into our infrastructure, we have equally two divided part, 33, 33, 33 for the infrastructure, 33 for the customer. Did you see that? So we create two subnets, 133 for the infrastructure, 133 for the customer. So block 2 and block 3, new block that we have, block 2 includes infrastructure plus our email, DNS servers and all sort of servers that we have, not the public hosting, but normal servers that we have, plus our customer side point-to-point and our customer network. All those things can be catered from block 2. And block 3 can be used entirely for customer IP block. And even for block 2 and 3, you can create your own ARPA domain, right? And registration option is optional. If you want, you can do the aggregated block registration. And SOR, not yet. Second opinion, not yet, because that's not for your customer anyway. I mean, second opinion is only applicable for end customer. All right, let's see the block number 2, how we did the further subnet. So block number 2 /33, we created a number of /48, right? First /48, which is block number 4, that we use for the loopback. And if we have a transport link it means all those POPs or the core routers are interconnected. So we have loopback, we have transport, and we have point-to-point infrastructure that can be catered from block number 4, right? Then block number 5, 6, 7 that you can use for your customer side point-to-point link, right? Because this area will be growing. So number of customers that we have, infrastructure customer side point-to-point link will also grow the same proportion. So that's why those we like separated from the infrastructure, because customer block we usually send via IBGP. So then we have our DNS mail and all sort of local server addresses. Then after that, we can use some address for the customers /48. So when I'm saying /48 per customer, it means if you have enterprise customer, you can give /48. Otherwise, what you can do, you can use /48 per your PPPoE or BDAS. For example, if you have a DSL customer, so right, for DSL customer, if you have 1000 port, 2000 port, right? So based on that, you aggregate a number of /48 and use that on that DSL PPPoE or BDAS server. All right, so this is how you can do some plan. So for the subnetting on block 4, so as you can see in the previous slide, we have block 4 that is for the infrastructure, our local data center, customer side point-to-point, right? So let's have a look for the detail on this one, this block number 4, loopback and point-to-point. So on block number 4, we created a number of 64. So first 64 that can be used for our loopback, a number of loopbacks that we have into our infrastructure, for example, all the routers. Then the second one probably the growth options. The third one we use for the transport. Fourth and fifth probably also the growth option. And then afterward you can go for infrastructure point-to-point. Each point-to-point link is /64. That's what we discussed before. All right. So this is how we have enough address to cater into the point-to-point point-to-point link within the infrastructure. We have enough address to cater transport. We have enough address to cater loopback. Those are all prefix, right? And after that, we need to build our interface ID. For loopback, we use manual. So 2406.6400 : 1 can be the first router, 2 can be the second router, : 3 can be the third router, right? So this is how we give address to the point-to-point link, loopback address. Same concept goes for the point-to-point link as well. All right, so then we'll see the customer block, which is block 3. That you can create a number of /48. Each /48 can be given to each customer if the customers are end users who need multi-homing, or that can go to your DHCP or BRAS pool, and from there you do /56 or /64 prefix delegation to your each DSL, WiMAX or 3G customers, right? So that's what you can do. So this is what an idea of a service provider network, right? This is what just an idea, a guideline. Another guideline, if you have a data center which is also growing, public hosting data center. In a public hosting data center, what we can do? We have a /32, we create a number of /36, right? So first /36, which is block number 2, that can be used for our infrastructure plus the data center, right? Where the data center is growing, and the other blocks go to the customer network. Let's have a look on block number 2, how we can cater into the data center. So that block number 2, we can further subnet it, right? When we further subnet that, we can subnet on a /40. So on /40, first /40 can goes for the loopback, transport, and point-to-point link, and that point-to-point link has included infrastructure and customer side. Then we have the second /40 that goes for the data center for public hosting, and for each customer that you have, you can give a /48 or /56. It's virtual hosting, right? So that's according to your plan. So you have enough address to cater huge number of public hosting into the data center. Then we see further detail of the loopback. So the first /48, which is from block 18, we use for loopback, transport, and infrastructure one. And did you see, or did you notice, whenever we cater loopback, transport, infrastructure, we always strict with the first available addresses. The reason behind that, this is how you'll have a very short and sweet IPv6 address for your loopback. So for example, if on your router 1, if you use the first available address, which is 2406.6400:0000:00:1, and if you need to do ping or in testing, so all loopback will have just the short address 2406.6400:1:2:3. So that's why it's always advisable to use the first available one into the loopback. So you'll have a very short and sweet loopback address for your network. Make sense? Any questions so far? Is there any question about how we are doing the plan? All good? Okay. Now we'll see the further detail of the loopback. As you can see from the /48, which is block 19, we can create a number of /64, and from there we cater first /64 for the loopback, and then third one for the transport, because the growth option either in the loopback or in the transport. Then we use a number of blocks for the infrastructure point-to-point link, right? So yeah, so this is how we can grow into the infrastructure. Now we come to the customer side. Even on the customer side, we have blocks. So for example, block number 3, that is for the customer block, we create a number of /48. So when we create /48, 36 up to 48, so we have nearly around 14 bit, right? 2 to the 2 raised to 14 is such a big number of customer block that you can create all with /48. Make sense? Okay. Addressing tools, sometimes, like, when you do the addressing in IPv6, those are the address management software. Some of them are, I mean, most of them are free, I think. Yeah. So those address management software you can use to kind of automate your address distribution, and that will be very easy for you to manage your infrastructure. So, for example, any of your customer coming today, you just add that customer into your address management and give them the address. Then the address management software will trigger all the configuration changes that you need to do from the change management system. That will push all those information to the routers, and also your DNS can also be updated with the customer addresses. So address management software is very useful, and we have outlined few options for you. Just have a look which one is best suiting your requirement, and all those software that we listed here support IPv6. All right, so this is what the presentation that we have for today. As I said, this slide will be shared into the FTP side. This is what the FTP side. And if you have any question, we can take the question now because we have some time to take the question. There is a URL here which is www.servermonkey.com/s/epic-2013-0213-el2. From there, if you just give us some feedback, so your feedback is very important for us, and when you finish the feedback, then it will redirect you to the FTP site from where you can download the presentation that we did. Okay, so someone wants us to share this into the chat box. Unfortunately, I can't copy it from here because it's in the PDF. Yeah, I mean, I can't just copy it in the chat box. Sorry, yeah, I can't copy it because that goes to our e-learning platform, and from there I can't copy it. That's not edit mode. I can't edit it, so I can't copy it. So yeah, but this is what that feedback URL that you can use. I was trying to copy it, but I can't anyway. So yeah, so that's what the presentation that we have. When you finish the survey, it will redirect you to the FTP site. From there, you can download the presentation. And if you have any question, any further question, so you can ask the question by sending an email to training@epinic.net. And then we'll try to answer your question. And if you have any other question related to Epinic and your operational issues, like how you manage the reverse DNS for your prefix, and how you can register things in the WIS database, come to our help desk. Epinic runs an extended help desk that runs from 9 a.m. to 9 p.m. in Brisbane time. Brisbane time is GMT +10. So we have online help desk chat, so you can just come to the help desk page from the website, Epinic homepage. Then you can chat with our help desk staff. It's very interactive. It's almost free of cost, I believe, because internet is available everywhere. Yeah, so it's a good help for you. So I hope the presentation will be useful for you. And thank you very much for listening to us, and hope we can see you in our future e-learning session. So that's what the help desk, and I'll just show you this slide to point you to the help desk. This is what the help desk homepage, and here you have that online link. If you click here, that will take you to the chat page, and from there you can do chat with the help desk staff. Okay. Yeah. All right. Then thank you very much. Thanks for attending our e-learning session.